Yes.
I got one for you.
Which one is this?
Okay. Let me first ask, how tall are you?
5 feet 10 inches. Or 11.
Okay.
If it's for a casting director.
All right. Are you not 5'10" and a half? 5'10" and a quarter?
Nobody believes you when you say that, though.
Okay, but you're talking to me.
Okay.
I'm your friend.
5'10" and a half could work for me.
Okay.
Yeah.
Okay. I've heard people say, I'm exactly 5'10". And I say, what do you mean by that? If I want to just be a pain in the ass. So what do you mean? Well, it came in exactly 5'10".
Right.
Well, if you look at a tape measure, okay?
Okay.
And you go to like 5'10",
Right.
The mark that indicates 5'10" has a thickness.
Okay. So then, are
So-
you saying
so
that
where were you-
thickness? Wait a minute. Are you, no.
So what I'm saying is,
So you're saying that?
yeah, what?
Where do you fall in the thickness of the mark?
Correct.
And then that determines your exact whatever measurement?
What I'm saying is that if you're measuring something, you can never know the answer exactly. It will only be an approximation that you just agree to and move on.
I disagree.
Okay. well, let's keep going. Okay.
Because I think if that what you said were true, we couldn't have that atomic clock you told me about.
Oh, well. Ooh, did you remember stuff?
I remember things.
Okay,
That's right.
so let me tell you about the atomic clock.
Okay.
When did I tell you about the atomic
You
clock?
told me about the atomic clock and about how the fact that because measurement of time was not at one point precise.
Right.
Okay.
Okay.
And that basically you wouldn't have the same time one place as you would the other because you didn't have
Well, the measurement of time.
wouldn't be.
So we went to an atomic time,
Right.
rather than Earth's rotation.
Earth's rotation.
And by the way,
And the other thing too was that the Earth's rotation is not the same.
we didn't know that, and you can't know that if Earth is your measure.
This is true.
So you offload the precision measurement to an atom, and the atom has very high dependability in its frequency that's vibrating. You get how many times it vibrates per second. It's the cesium atom. You do that, you get that. Now you look back at Earth and say, oh my gosh, Earth is slowing down.
Right.
You could not have known that
Without that,
if Earth was your measure.
if Earth were the means of measuring, you would never know that.
Correct.
Because the mean itself is actually slowing down.
Correct.
Right.
Okay, so all I'm saying is when you make a measurement, you can never know anything precisely. You can only know it to some point where you agree. So here's the best example.
Okay.
It's related to how tall you are.
All right.
The best example. I ask you, how long is
By the way, I'm 6 hands tall.
that would only be, so a hand is 4 inches.
Oh, forget
So
it.
you,
I forget the
I
one that
think
they.
a hand is 4 inches.
I don't know. I thought I was using the one with horses, but go ahead.
Right, the hand.
Hands,
right,
is it? Okay,
Right,
forget
okay.
it.
So, you don't say how many feet tall, how many hoofs tall.
How many hoofs tall are you?
So, the coastline of England,
All right.
okay, how long is it? How would you go about finding that out?
Well, you would have to measure the actual squiggly line.
Squiggly line. Okay,
Right.
so you get out a
So
map.
that's the
you get a
actual
map,
coastline.
Get a nice big map.
Right.
And you get a squiggly line. You
Right.
can't put a ruler up against it because it's squiggly.
Right.
So what do? You get like a string. Okay? You take the string and you do that.
Right.
And you come at it, and then when you're done, you undo
pull it
it
out.
and you hold it up against the scale. You say, oh, it's 800 miles long.
Okay.
Whatever. I don't know the exact number.
Right.
So there it is. But wait a minute. If I had a bigger map, it would show more squiggles, wouldn't it?
Okay.
So with a bigger map, if I do this exercise again, my string is doing more as it goes around.
Now I got more string and a bigger measurement.
So it's not just that it's a bigger map. Of course, the scale is bigger, but my string did more
Right.
because I got more detail.
Okay.
So which length of the coastline of England are you going to use? The one from the small map or the one of the bigger map? Probably the one of the big map is going to be more precise for you.
Right.
Are you done? No. Let's make it even bigger. In fact, let's make a map the size of England.
Okay.
And now
I
go
don't think
around the
we would
coast.
have to do that because England's there.
England's there. So now you just go around with
a
the
string.
No, wait a minute. There's a
Which
boulder.
guys do that.
Wait, there's a boulder there. Which side of the boulder are you going to go around? Wait a minute. The tide is coming in and out. The coastline is the boundary between land and water. But the water is not constant. Where are you going to draw that? Then you get down to the sand. Which sand grain are you going to go around? What I'm telling you is,
You're making me not believe in maps.
what I'm telling you is, you can measure the circumference of Colorado, okay, because it's got square sides. But when you got squiggly lines, that measurement is an agreed upon point where you're going to say, I give up. Let's just call it this.
Is. All right.
That's my point.
That's the point.
Right. And you can say, is that you make a measure at high tide or at low tide?
Right.
Or at in-between tide. All right? You have to pick. You have to, at some point, you just have to say, we're done here.
Gotcha.
Okay? How much do you weigh? Okay. I got a scale here. All right? I got a scale. This is like a kitchen scale.
Okay.
And I turn it on. And it measures, you do
the tear and all that.
You do tear and all that, and it'll say, let's say, 3 ounces. Okay. Is it 3 1/4 ounces? It doesn't register that. It'll only register again when it hits 4 ounces.
True.
Right. So it can't measure. This scale cannot measure between 3 and 4 ounces.
Right.
Now let's get another scale that goes through tenths of an ounce.
Okay.
So now you get 3.2 ounces, 3.4 ounces.
Okay.
What's the next 3.5? Suppose it's in between those.
Okay, so
can't
now
measure that.
So now I got a scale that does.
Now you got a scale that goes to 2 decimal places, and you can take that all the way down.
Right. Wait a minute. See now,
It's ugly. It is ugly.
Exactly, because now you have made scales and weights into fractals. Because I'm like,
yes,
you can just keep going.
You keep going all the way down
through, but you never get.
You'll never ever, because it'll always be the thickness of the line that you're doing the measurement with. It will always have a thickness. So you can measure things to some approximation that we all conversationally agree with, but you will never, I don't care what it is. By the way, you can count precisely. There are exactly 2 of us here on this set. Okay?
Right.
There's not 2.5. We can count that.
Are we counting the voices in my head?
3.5. 2.2. You have 3/4 of a voice. I got 1/4. We got 3. So you can count things precisely. You cannot measure with unlimited precision.
Interesting.
Yes.
But see, now, okay, yeah.
Now, here's what happened.
Right.
Just this past year.
All right.
The kilogram.
Something I know nothing about because I'm American.
American non-drug dealer.
That's right.
How many kilos? In the International System of Measures that keeps track of the length of the second and the duration of a second, the length of a meter, and the mass in a kilogram. The last thing based on an artifact in that facility was a kilogram.
Was the kilogram?
Yes. Everything else is based on measurements of on highly precise things that you can duplicate in laboratories. Okay. This was an artifact sitting there. That's a kilogram by definition.
Right.
Okay?
Right.
They said we can't do this anymore. You know why? Because they made copies of it, put them around the world, and every now and then they bring them back, and none of them are equal anymore. Some are losing atoms. So they said we got to fix this.
So that little thing that you see, that when it says
it's
kilogram,
a platinum iridium
it's
thing.
Yeah.
Okay.
That little cylindrical with the little handle on the top.
Well, that's when they're doing the thing. Right. Correct.
So you're saying that no longer is the proper measurement of a kilogram?
As of the middle of 2019. That's correct. No longer. Because here's what they did. We have ways of making precise crystals of silicon.
Uh-oh.
So precise that you can count the atoms in the lattice.
That's pretty cool.
So what they did was they took the kilogram.
That's dope.
It's dope. They took the kilogram,
right,
and then they made a silicon sphere, pure silicon, and they made them equal each other.
Right.
Okay. Once you do that, you throw away the kilogram.
Right.
And now I know exactly how many silicon atoms equals a kilogram.
So now I have an atomic representation of what the kilogram measurement is.
And I can count the atoms. So there is no uncertainty in the mass of the kilogram right now. And I can tell people around the world, you want a kilogram, assemble this many silicon atoms. And you know what also that does?
Go ahead.
It sets Avocado's number.
What?
Do you remember him? That's what
Avogadro's
number. Do you remember?
Avocado's number.
Sorry. Remember, it was 6.02 times 10 to the 23rd. It's how many particles make a mole.
Right.
All right. Once you set the kilogram with the silicon atoms, you set how many particles are in a mole. We set Avogadro's number, and it's now to 9 decimal places.
That is amazing.
We got this.
That's pretty cool.
Done.
That's cool.
So it's true for everything you measure. On the speedometer, your weight, the time, the temperature. There's always some range across the indicator where it could be at the bottom, the middle, or the top. Make a thinner one, there's going to be a bottom, middle, or top. You will be doing that all the way down.
That makes sense.
That is the world of measurement.
So here we go, people. What have we learned? Believe nothing.
No, just there's a point where we say, we're good. You're 5'10".
We have to agree.
I'm good with that.
I'm cool with that.
You're not 5'8", you're not 6 feet. I'm good with it.
I'm going to be 5'8" and say I'm 5'10". Forget it.
Anyway, this has been a StarTalk info bit. Thanks, Chuck.
Yeah, no
for
worries.
helping me through it.
By the way, byte, 8 bits.
No, isn't it bit 8 bytes?
I was about to say it depends on what you're eating.
Keep looking up.